Welcome, everyone. Good day to you. Thank you for joining us today. I am Nancy Regan, and I am joined by Graham Stephen, Chris James, and Jesus Safante. Not with us today is Mark Horton, but we are the IRCC, the International Reliability Centered Maintenance Certification Committee, and we are dedicated to helping organizations implement RCM properly and get the best out of their analysis by making sure their team members understand what true RCM is all about. We are delighted to be here today, and welcome Suresh, and welcome John. And Suresh, you are joining us from Saudi Arabia. That is pretty incredible. I'm not at home today. I'm in Las Vegas, Nevada, and so I think it's important to say it's okay to gamble at the tables, but it's not okay to gamble with your proactive maintenance. And we've got something very special to share with you today. Chris James, who has been doing reliability-centered maintenance for over 25 years. He worked directly with John Mowbray for more than 11 years and created a lot of RCM training content. Some of the information that you find in John Mowbray's best-selling book, RCM2, Chris helped develop much of the material that you find in that book. And today, he is going to talk to us about, I've got it right here. Well, I don't have it on the screen, but he's going to talk to us about OEM, the manufacturer recommended proactive maintenance, and why it's important to challenge that and not take a gamble and just do the maintenance that the manufacturer says. So after Chris presents that, we're going to talk a little bit about RCM Level 1 certification, but without any further ado, I'm going to hand it over to Chris, who is going to talk to us about OEM recommendations. So take it away, Chris.
Thanks, Nancy. And I think really this little micro module came up really from some of the feedback we had on previous sessions. Actually, quite a lot of discussion. I think on our initial launch about OEM recommendations. So we felt it'd be a good topic just to discuss and explore a little bit. So RCM is a systematic, objective, structured, scientific process to determine your maintenance requirements, both in terms of the tasks that you want to do and the intervals for those tasks. Now, when I run RCM training courses, I like to have a bit of fun and explore the alternatives to RCM, to consider if you don't have a systematic, scientific, objective approach, what are the alternatives? Where might your maintenance program come from? And when you think about it, when you look at it, it becomes very clear actually that there is really no good and no powerful alternative to RCM. Some of the things that people would, some of the alternatives to doing applying RCM to determine your maintenance requirements could include things like, well, doing nothing, letting everything run to failure, which is clearly not a good approach. Other people sometimes say, well, you could always do what you've always done for the past 10, 20, 50, 100 years or whatever, which is obviously not a good approach. Maybe you can do, sometimes people say, well, you do maintenance just because you can get access to the equipment. And that's also not necessarily a good idea, because your access may be intermittent or maybe at an inappropriate interval. Some people seem to apply what I might call the sample of one. They add maintenance whenever they have a failure, but without fully understanding the root causes. And if you do that, then you risk having a thoroughly sort of excessive and possibly counterproductive maintenance system, etc. And whichever way you look at it, in many of these alternatives seem to be a bit flawed, and you come back to the fact that you need to have a good systematic scientific approach for determining your maintenance requirements. But one of these, and we're not going to explore these other options, we could explore these all today, but the one I would like to explore in a little bit more detail now is what people often mention, and that is as a source of their existing maintenance program, and that is OEM recommendations. Why OEM recommendations are often suboptimal and why they should always be challenged. So whenever I mention OEM recommendations, the first thing that people normally say is that, of course, OEMs like to sell spares. People say that, well, often they don't make much money. They make more money from selling spares. Often they don't make much money from their initial project, and they like to recoup some of that money by selling used spares. So they'll recommend, unnecessary replacements of components. They'll recommend unnecessary maintenance simply to make a bit more money and from selling spares. Now, I don't think surely it's fair to tar all OEMs with the same brush here. Surely most of them would not do such things. But certainly, so I tend to disagree with people a little bit here. But certainly, the suspicion does remain amongst many of the delegates that I come across on my training courses that is the agenda for some OEMs. I think one thing we can all agree on is that although they know a lot about their equipment, hopefully, they don't know the whole story. They don't know the context in which their equipment operates, and they don't normally adjust their recommendations to the context. And so inevitably, the context that they will be assuming to cover everything is going to have to be a worst case context. And so it might be worst case in terms of running time. It might be worst case in terms of, worst case environmental conditions. It might be worst case in terms of the load that the equipment is running at. And if these worst case conditions don't apply, and you apply those recommendations, your maintenance may be suboptimal and expensive. Furthermore, they don't always know the whole story in other ways. For example, they don't always know what sort of instruments have been fitted to the equipment around their equipment, instruments that could be used as the basis of some condition-based activities to infer the condition of their equipment. And so they can't include that in their recommendations. And they don't know what sort of condition monitoring equipment you've got access to. They don't know whether you can do vibration analysis or thermography or ultrasonic inspection or oil analysis and all that. And so, they can't assume you do those sorts of things. And so often they don't take those sorts of things into account. Well, in many cases they don't. And so, consequently, their recommendations tend to be sort of fairly lower level human inspections using the human senses, things that they know you do have that may be unnecessarily invasive, or they may be focused a little bit more on traditional fixed time preventive overhauls and replacements, which can often be massively suboptimal compared with modern condition monitoring techniques. And another thing about the OEMs is that they do tend to focus really solely on their equipment. They don't know how it fits into the process, and so they don't know the implications of the maintenance of their equipment. And they just tend to think about their equipment in isolation. I remember visiting one OEM and talking to one of their designers, and his definition of safety was actually safety of the equipment. And so their control system was designed to shut down the equipment whenever anything went wrong with it. Because as far as they were concerned, that was the best thing for their equipment, just to be sure that it was okay. And they weren't aware, and didn't seem particularly bothered about the implications on the wider system that their piece of equipment was supporting. And their maintenance program was much the same. Their maintenance program was very conservative and very cautious because they were just thinking about their equipment. And they weren't thinking about the implications on the wider process. And I've recently been doing a big project on a transmission system in the wind power industry. And I got a couple of examples of this actually, which are very interesting. One of them was what's called neutral earthing resistors, and these were in place. These were fitted near transformers, and they were there to prevent damage to the transformer in the event of an earth fault. Now, the OEM for the neutral earthing resistors, just thinking about their neutral earthing resistors in isolation, decided that it would be a good thing every 6 months to take the neutral earthing resistors apart, have a look at them, and put them back together again. Unfortunately, the neutral earthing resistors weren't connected to the, were directly connected to the transformer. And so in order to do that, you'd have to shut down the transformer and reduce your capacity, and possibly have to shut down parts of the wind farm because you couldn't transmit the electricity. Now, the manufacturers of the neutral earthing resistors weren't aware of all that, and they weren't really considering all that because they were just thinking about their equipment. And we found the same with cables. The cable OEMs, thinking about the cables in isolation. If you're an engineer, what's the best thing you can do for your cables? Well, they said, well, what you should do every 6 months on the cables is do a sheath test to measure the resistance of the sheath of the cables. Now, that's all well and good if you've got a spare cable, perhaps. But if you don't, of course, to do that test, you have to shut down to do that test, and therefore you might lose capacity, you might lose income, you might lose transmission capability, you might lose income. But of course, the OEM for the cable supplier wasn't thinking about that because that wasn't part of their agenda. And this issue is further exacerbated by the fact that what you tend to find, particularly on larger projects and larger pieces of equipment, is that you get the main contractor will buy components from subcontractors who will buy components from subcontractors, and the manufacturers of the original components will often provide their own maintenance recommendations, which then get fed through unchallenged all the way through to the final customer by the other contractors that they've been contracted to. And so there's a further disconnect between the process that the equipment is being used in and the original supplier of some of the original components. And if you think about it, these people that design and specify equipment often do a really good job. They're clever engineers. They do some good work, but they are not maintenance experts. They don't have the time, they don't have the experience, and they don't have the incentive to carefully consider maintenance requirements and keep up to date with the development of maintenance techniques. And furthermore, if your maintenance techniques have been developed, the OEM recommendations are quite old and you've got old equipment, it may be that those techniques are way out of date. And the OEM recommendations are way out of date. And there's been massive explosion in new condition monitoring techniques over the past 20, 30, 40 years, and development of those techniques and the applications of those techniques. And of course, if your OEM recommendations are old, or indeed you've got old equipment, then maintenance techniques might have improved since then. And so there can be better maintenance techniques available. So, whichever way, if you look at it, in many situations, one or many of these factors apply, which means that OEM recommendations, whereas they might be a good starting point, it's worth challenging them. And of course, RCM provides a good process in which you can challenge those OEM recommendations. Now, I've got 3 case studies now from my own experience with just these, some examples of many of these principles that I'm going to share with you. Unless, of course, Nancy, you have there are some questions we want to, or any comments from anybody else you want to add, then I'll move on to these case studies.
Yeah, there are a couple of comments that I would like to highlight. And in the meantime, Chris, you're sharing on presenter mode, so the presenter screen. So maybe while we're going over these comments, you can just switch to the full screen.
Yeah, thank you.
But yes, Andy has made a couple of good comments. Asset manufacturers make, not run assets. And he's saying, as you point out, they know little about the operation or the context. Absolutely. And then let's see. And then Lennox said, more OEM needs to practice design for maintainability. Absolutely. And he also says lack of systematic approach to maintenance design and planning. It's all 100%. And, you know, one thing that came to my mind while you were talking about this from just a super simple perspective is, you know how if you're having a problem in your own life and you maybe go to a friend and talk to them and, you know, you give them some of the details and then, you know, you might say, well, what do you think I should do? And maybe you ask for their advice and they give it to you. And the advice they give you may seem like, whoa, you know, it's not that bad, or I can't do that right now. That's because their perspective is very limited and they don't have all of the information. And it's the same thing about our assets, right? The OEM knows their machine, but they don't know how we're going to use it. They don't know our intentions.
And it's very interesting. Yeah, I think it's a very good point there. And if you look at what the aircraft industry does and the way that they work, you know, it's a lot more collaborative, the approach that they have between the manufacturers, the users, and the regulators. And RCM or MSG3 provides the link between all of those, but they work together. And what tends to happen in other industries is people throw things over the fence, don't they? You know, people maybe there's more bullet points here, but people design things, they move on. They need to tick those boxes. They move on. They don't design for maintainability, but they throw something over to the fence, and then someone else has to decide how to maintain it and how to operate. And it's not joined up and it's not linked as well as it should be, and as well as it is in other industries that have a better record in terms of reliability and maintenance. So yeah, that's a very good point.
Excellent point. And you bring up another point, Chris, where when it comes to RCM, and I know all of us here online in the IRCC, we advocate a facilitated working group approach to the process. And it's just because of what you just said, right? Because even within an organization, operators have one perspective and maintainers have a perspective, and engineers certainly have a different perspective. And when you get all those perspectives together, all kinds of information starts to surface, and sometimes you know, information that people within the organization didn't even know. What are your thoughts about that, Chris?
Most certainly. Yeah, it's amazing. That's what the things that people discover and people understand when they do that, when they work together. And I was only last week running a project with a pharmaceutical company, and it was amazing how much people who had actually been working on some of their equipment for 20 years, they learned from each other. And we had an OEM in the course in the project, and that was so useful. They learned so much. Yeah. So OEMs, you know, they do know part of the story, but they don't know the whole story. So let me move on to some of these case studies, because a lot of these bullet points here apply to some of these case studies from own experience, and I imagine everybody else has got their own stories. So the first one I would share is in the oil and gas industry, and this was actually an old compressor, a reciprocating compressor using condensate recovery. So what they did is they took they took hydrocarbons and they took the gas, but it was rich in certain hydrocarbons that would became condensate, and so they needed to recover that condensate. And so what they did is this reciprocating pressure was part of a condensate recovery system. They basically compressed it and cooled it and recovered that condensate. And the OEM recommended, actually they did recommend, to their credit, they were old compressors and an old maintenance program, but to their credit, they did recommend condition-based maintenance at least, but it was a very invasive condition-based maintenance. And basically it involved shutting down the compressors and taking them apart, measuring everything, looking for wear, and putting them back together again. And when they did this, they kept oil production going, so it meant that the condensate recovery couldn't take place, and they had to flare the condensate that wasn't being recovered anymore. And which caused big environmental concerns. You know, it was a lot of condensate. So what we did is we did an Rcm analysis, and what was interesting, you know, these were very old compressors and a very old maintenance program, but you know, maintenance had moved on. And what we found is that for every failure mode managed by their traditional old-fashioned maintenance program, there were new techniques that could be applied that would allow your condition of the compressors to be determined without shutting them down. You know, things like vibration analysis and oil analysis and things like that, as well as some human senses. And so the result of that was a massive reduction in flaring, and actually a knock-on effect, because they weren't taking the things apart and putting them back together again. They got improved reliability because they were carrying out much less invasive maintenance. Okay, so another example, and this really to me is perhaps the biggest proof that OEM recommendations are there to be challenged, because this is a project I actually did with an OEM. And so this is a manufacturer of gas turbines, and what triggered this work was the fact that they had a change in their business model. So what they used to do, they used to sell their gas turbines to their customers, who then did the maintenance, and they would recommend the maintenance to their customers. And then they started offering service contracts. So in other words, you know, what would happen is their customers would pay them a certain amount of money, and they would do the maintenance for their customers just in receipt of a fixed sum per year. And in other words, what this meant was that the big change here was that the OEM was responsible for the cost of maintenance, and all of a sudden there was an incentive for them to find savings. And so, you know, I did RCM work with them on their gas turbines, and what was amazing is that we found some quite big savings. And one of the biggest areas of savings actually was in instrument maintenance, particularly on and that was one of the biggest drivers of their cost, because they're gas turbines. You know, it's like a car these days. You know, you buy a modern car and it's a computer with an engine and wheels bolted on. You know, but it's, you know, these gas turbines had loads and loads of instruments, and the biggest contributor to maintenance cost and downtime for preventive maintenance and predictive maintenance and planned maintenance was actually instrument maintenance. And we found big opportunities to improve that through doing RCM on their instruments. And then the final one I would share was in a large fleet of trucks, again in the oil industry. And this is one of those projects where I wish I'd negotiated a fee based on the proportion of the savings that were identified, because these trucks had loads of hydraulic systems, loads of oil systems. They had large diesel engines, and they had lots of oil systems in hydraulic systems, and also sort of axe oil and things like that. And their maintenance that they applied to this fleet of trucks came from the OEM, and it was entirely time-based. It was fixed time replacements of oils and filters and things. And the biggest costs that they had actually in this fleet of trucks included things like fuel and tires, but they couldn't do much about. But the next came oil and oil filters. Okay, and so we did. Well, this could be quite a targeted RCM actually, and that's what we did because we didn't have a lot of time. But I applied RCM to particular failure modes driven by the context. And you know, a big finding there was to do the replacement of the oil and the filters based on the condition of the oil and the filters rather than on a fixed time basis. And some of these oils they were replacing every 250 operating hours, which was actually, you know, these were running 24/7, these trucks. So it's actually 10 days. And the savings per year, they ran into many millions per year over a fleet of trucks. So a move to condition-based maintenance away from OEM recommendations. So 3 examples. There are probably many more. Hopefully some more have come in, or some of the other guys have got some examples. But you know, loads of examples of how, you know, to illustrate that OEM recommendations are worth challenging, and you shouldn't just accept them blindly. And RCM, of course, provides a mechanism for doing just that.
Yes, thank you, Chris. And That is, it's a very illuminating topic. Lee put in the chat, generally speaking, he's not sure it's fair to blanket suggest that OEMs lack systems thinking or should adopt a design for maintenance process. And he goes on about that topic. And thank you, Lee. Yes, your point is well taken. And I think, I don't want to speak for you, Chris, but my understanding is that we're not saying OEM recommendations are bad or the OEM doesn't know what they're talking about. It's that we should take them into account, but to challenge them or sanity check them. What are your thoughts about that, Chris?
Oh, yeah, most certainly. Yeah. That's a good starting point. Yeah, and there's a good starting point. You take the recommendations, you infer the failure modes, and maybe you adjust based on those particular failure modes. Yeah. They make a good starting point. Yeah.
So when I first started doing RCM, it was for when I was a civilian employee of the Navy, and we did it on fleets of vehicles. And Chris, you were at that time, when I was just starting out, you were very generous with your time and your knowledge with me. And so I would just like to acknowledge that and thank you for that. But we realized similar results that you just talked about with the fleet of trucks. And part of it is that the Navy was blindly taking the manufacturer's recommendations. So just for example, on a tow tractor that the Navy was using, just a few hours, a few times a week, they were doing proactive maintenance as if it was being used, like UPS, maybe 15 hours a day, 5 days a week or something like that. So the operational tempo in the environment, it all plays in. So I echo what you found with your analysis. We found the similar things within the Navy.
And actually that was quite a massive change then, wasn't it? Because if their recommendations were assuming continuous operation, you were only using it a few hours per year?
A few hours per week.
Per week, fair enough. Okay.
Yeah,
well, okay.
But it was an aircraft tow tractor. Mm-hmm.
So still a very small proportion then?
Yes, yeah, okay. Very much so. Chris, Jeff makes a point that maybe you can talk about this, where he's talking about the OEM warranty period. So maybe you can talk about that, what do you do about those tasks that the OEM says, hey, if you don't do this?
Yeah, that's a good question. And that's a very good question. This came up as quite a big issue in the wind farm project, actually. What I would say is that the warranty period is normally quite short compared with the full term operation of the equipment. So I think we should consider the full term operation, really. I don't think it's wise to go without discussing with the OEM breaking their warranty recommendations. That's certainly not recommended. So really, I think you should aim to follow that, but maybe challenge it. Maybe, if you come back to the failure modes that seem to be covered under their warranty recommendations, and challenge those, particularly those that seem to be the most expensive. Maybe you've got a basis for challenging it. But I think, I think you follow what's required for warranty purposes, at least as a starting point. Yeah. You have to. Yeah,
and Lee clarified that his comment was in response to some other comments, so I would like to acknowledge that, but it still brings up a good topic, that a good point, that we're certainly not saying don't pay attention to them, but rather just challenge them.
One thing I did find with warranties is that actually, by the time a lot of the equipment came into operation, a lot of it had almost finished its warranty period, because some of it had been purchased. It really depends on the wording, but of the contracts. But when the warranty period began, and a lot of the equipment, by the time it was actually being used, the warranty period had almost expired. So it didn't really cover a large portion of time. In some cases.
All right. Well, thank you for that, Chris. Any other last minute thoughts, or Jesus or Graham, if you have any thoughts before we wrap up this topic?
I just want to thank Chris for the information, and congratulations Chris, on a very informative presentation, and also for sharing your experience with actual cases. Thank you very much.
Thank you. Thank you. What I would say in response to I can't remember the guy's name earlier. I try not to say things in absolutes as always, or this is always the case. But sometimes the case. Sometimes they don't. Maybe I should put some sometimes in there. Yeah.
Well, there are definitely no absolutes in life, right? In any case. Well, thank you, Chris. Okay, so if you do have any last minute questions for Chris, you can put them in the chat and we can circle back around to them. But let's just very briefly talk about level 1 Rcm certification. So let's see, Chris, would you mind sharing our website? Because now through, let me see, if you go to our website, I'm going to put it on the bottom of the screen. It's rcmcertification.org. This is our website. And right now we are offering level 1 Rcm certification at 50% off, but only through April 30th. And if you do want to take advantage of this, but you're not ready to take the exam yet, you can still purchase access to the exam, and that will be good for up to a year that you'll have to actually take the exam. So if you want to take advantage of that, you can just go to our homepage and click on that Get Level 1 Certification Now. And that will bring you to the purchase page. And where you see click here to enter your code, I'm going to put the code up. The code is Rcm50. So if you just type Rcm50 right there in that coupon code, you will see that it reduces the price by half. So we would be delighted for you to join us in that. And there we go. So that's how you work it. Now, the last thing I will say is we're going to be coming back live again for sure. If you would like to be notified of our upcoming lives and any new information that we have coming out about Rcm certification, because we're working diligently on level 2 certification, you can go to rcmcertification.org/subscribe and just enter your name and email address, and then we'll let you know of the good stuff that we've got coming up. But speaking of good things coming up, we've got an incredible double-header coming up, and it involves Jesus Safante. A week from today, we're going to have another live event where Jesus is going to talk about common FMEA or failure modes and effects analysis, common pitfalls that can very possibly be increasing your costs and compromising your safety. And the big deal about this is he's going to do the first half in English and the second half in Spanish. So Jesus, would you give us a little coming attraction of what you're going to talk about next week?
Sure. I'm delighted to be speaking about FMEA, how to put together a compliant FMEA. So I will demonstrate or give you some examples of how to do it correctly. I will also show a couple of common pitfalls that you see again and again, and we'll explain how they can curtail your, let's say, benefits, and we really want you to be aware of that and avoid them. So I'm also glad that I will be doing it again in 2 languages, English and Spanish. So if you have some Spanish-speaking colleagues at your facilities, invite them. And first half of the hour will be in English, and then I will be speaking in Spanish, as Nancy says. So I'm really excited to. Can we start today, Nancy? Or we have to wait until next week, right?
Do you want to share that you could share it in Spanish if you like. Is that what you mean, Jesus?
No. Just I'm just so excited to speak about it, so I can't wait for next week.
Yeah. Oh, I'm so glad. That is going to be a really incredible topic. And oh my gosh, Jesus, it's so incredible that you can speak more than one language, because you also speak Portuguese, I understand,
Well,
right?
yeah, I know a little bit. I can go, and speak a bit of Portuguese and get away with what I want.
Okay.
At least.
Okay, but next week, a double header. You're like a switch hitter in baseball, right? You can bat left-handed and right-handed.
Being from Puerto Rico, I was more a baseball fan. Yes.
Yeah, me too. I'm from Boston. The Red Sox were like a religion growing up.
I'm a switch hitter, yes.
Yeah, switch hitter. All right. Well, thank you so much, everyone, for joining us. Thank you, Chris, especially for sharing all of that. Thank you for being so generous with your knowledge and your experience. And we will look forward to seeing all of you next week for an English and Spanish presentation. So any last thoughts from anyone? All right. I guess that's it. We will see all of you a week from today, Wednesday, May 5th, same time, 9 a.m. Central. Have a wonderful rest of your week, and we'll see you next time. Bye-bye.
Bye-bye.
Bye.